is John Duncan. Welcome to the second installment of Drugs in the Brain, Drugs of Abuse. This is part 2. In this particular video, we're going to look at opioids, particularly those that are most abused: heroin, morphine, oxycodone, and hydrocodone. Opioids and the brain. Heroin, morphine, oxycodone, hydrocodone. They cross the blood-brain barrier, enter the neuron. They mimic natural neurotransmitters in the brain, seeking to bind with the mu-opioid receptors. And then we can see a change in the brain's chemistry. We can also see a change in a person's values and their behaviors. Question is, what leads to this? Let's look more closely. In the brain, opioids bind to a number of different mu receptors. That's the Greek letter mu. And they are pretty well scattered throughout the brain. But we can see here in the kind of a light blue color that they're in the frontal lobe, which is downgraded. It slows things down. It runs slower. So our frontal lobe activities are not quite as on par as if we didn't do heroin. Our thinking becomes slower, and this is progressive. Less control of our inhibitions. Poor goal-related behaviors, unable to do those basic things in life as well. This is where pain management is, and also it suppresses a lot of our motor skills. And then the reward pathway, we're going to develop more and more craving. We're going to form habits, and these habits will then affect our compulsive drug-seeking behavior, otherwise known as addiction. We can see that the thalamus is an area associated with the relief of pain, changing of the nucleus accumbens, which we've talked about in the past. We can see a little closer view of that particular part of the brain. Right in the front part, it's the blue piece right there in the center. Part of the reward system. In fact, it is the behavioral reward incentive saliency center in the brain. We can see this affected greatly and quickly with heroin abuse. Pretty much what happens, we have 3 phases. The opioid receptor, on the one hand, is occupied by opioids, heroin, hydrocodone, any of the opioids. It causes an activation in the opioid nerve that communicates in the next slide. We can see how it moves across from the opioid binding site to another nerve. This other nerve happens to be dopamine, and plugs right into the reward system. As that happens, we see the release of dopamine, in this case, neurotransmitters, and they bind to another nerve, dendrite, to that blue receptor molecule there. And this causes an effect. When they're binding there, it causes a neurological effect that runs throughout that particular nerve. And reward is the ultimate product of this, a feeling of intense reward and pleasure. So this pleasure exists as we do the drug, but it's not necessarily happiness or the pleasure we associate ourselves with. Opioids change the brain. And this is the brain we're left with after 7 years. 7 years on heroin. In this particular brain, we can see a marked decrease in overall brain activity. It's just global brain downregulation. The frontal lobes are disengaged. This is the executive control part of the brain. These are the parts that set your goals in life, that accomplish things, that think, that feel, that take care of business, that are aware of our world and give us energy in life. The parietal lobes, right below that. The parietal lobes, this is where pain regulation is, but it's also where our body sensation is. So we're down-regulating our body's sensation in the world. We're slowing it down. That's why heroin tends to mellow people out. They nod. They don't get up. They don't do things. They're not as active. The temporal lobes also down-regulated, reducing our memory, our language, our emotions. All of these types of brain damage destroy gradually our quality of life. And heroin does this. Not only that, but it activates the parts of the brain associated with addiction, with craving, with compulsive, repetitive, drug-seeking behavior.